Hello students, Namaskar to everyone. Myself Mukesh Kumar Chitpal, Assistant Professor, School of Agriculture, IT University, Gwalior. So today we are going to discuss about the first principle of differentiation. So what is first principle of differentiation and how can we find differentiation of any function with the help of first principle of differentiation. So the formula of first principle of differentiation is given here. Suppose we have a function fx. So we assume y is equal to fx. So to differentiate this y with respect to x, so we write dy by dx. And the formula is this lim is limit del x tends to 0. This arrow indicate tends to. So we call it as limit del x tends to 0. F x plus dx minus fx divided by del x. So what is x plus dx? So suppose we have given fx is equal to sin x. Okay. Then f x plus h x plus del x will be sin so in place of x we write x plus del x. So it becomes sin x plus del x. Okay. So this is the formula of calculating the differentiation of a function with the help of first principle. Okay. So today we will differentiate our two functions sin x and cos x and find its differentiation with the help of first principle of differentiation. The important formula that is used to differentiate sin x and cos x are sin c minus sin d is equal to 2 cos c plus d by 2 into sin c minus d by 2. Next formula is cos c minus cos d is equal to minus 2 sin c plus d by 2 into sin c minus d by 2. So these are the two important formulas which are used to differentiate sin x and cos x. Suppose we have given limit theta tends to 0. Then sin theta upon theta, the answer of sin theta upon theta when limit theta tends to 0 is equal to 1. So suppose we have given limit theta tends to 0, value of sin 90 upon 90 will be 1. So the angle may be 180, 270 or anything. Okay. So this is the important formula which is used when we find the differentiation of sin x and cos x by first principle. Now we start the differentiation of our first function sin x. So we have given fx is equal to sin x. Okay, then fx plus dx will be sin. So in place of x we write x plus del x. Now this is equation number 2 and this is equation number 1. So in this case we write equation 2 minus equation 1. Okay, so here in equation 2 fx plus dx, so it will be here. Okay, fx plus dx and minus this fx. From right hand side it is sin x plus dx minus sin x. Okay, now we solve this equation. So here we assume x plus dx is equal to c. Okay, and this x is equal to d. Okay, so this formula becomes sin c minus sin d. So the formula of sin c minus sin d is 2 cos c plus d by 2 into sin c minus d by 2. So this thing we write here. So 2 cos c plus d means x plus del x, then plus this x divided by 2 into sin c minus d. So c is your x plus del x minus d. D is your x. So this minus and this plus is cancelled. So what is remain here? Only del x. So this del x comes from there. So that is c minus d by 2. So due to that, in the denominator this 2 comes. Then this x and this x will be added and becomes 2x. So we write 2 cos 2x plus this del x divided by 2 into sin del x by 2. So we divide this the numerator by 2. So 2x upon 2 will be x and del x upon 2 here and 2 cos there sin del x by 2. So this is the solution of this sin x plus del x minus sin x. Now we write the formula of first principle of differentiation, that is dy by dx is equal to limit del x tends to 0 fx plus del x minus fx divided by del x. So this portion we have solved and we got this. So we write here divided by del x. So we write divided by del x. Okay. So this 2 from the numerator comes to the denominator and becomes del x divided by 2. And here 2 is not. And the remaining thing we write on the numerator. So this sin del x by 2 and this del x by 2 we write together. This. And here a thing that is missing, that is limit del x tends to 0. So when limit theta tends to 0, sin theta upon theta is 1. So here the angle theta is del x by 2. Angle is del x because limit del x tends to 0. When del x is 0, 0 by 2 is also 0. Okay, so this del x sine del x by 2 divided by del x by 2, the answer of this term is 1. So if this term is 1, if 1 is multiplied with this, so there is no effect on that. So what is remaining? Cos x plus del x by 2. But the limit is del x tends to 0. When the del x tends to 0, so here 0 by 2 is 0. We put the value of del x as 0 and 0 by 2 is 0. So what is remaining? Cos x. So this is our final answer. So dy by dx of sin x is cos x, and we know the differentiation of sin x is cos x. So this is our final answer. So in this question we have solved sin x by the use of first principle of differentiation. After that we solve the cos x with the help of first principle of differentiation. So here we have given for next question fx is equal to cos x. This is your equation number 1, and f x plus del x is equal to, we write cos, so in place of this x we write x plus del x. So we take it as equation number 2. Now we write equation number 2 minus equation number 1. So this is fx plus del x, so this we write here minus is fx equal to this cos x plus del x, then minus this cos x. So here also we assume that x plus del x is equal to c and x is equal to d, and the formula of cos c minus cos d is minus 2 sine c plus d by 2 into sine c minus d by 2. So here your c is this and d is this, so it becomes cos c minus cos d. So now we use this formula to find the solution of cos x plus del x minus cos x. Okay, so we write here this cos x plus del x minus cos x here, and the formula is minus 2 sine, so we write minus 2 sine c plus d by 2. So your c is x plus del x and your d is x, so c plus d divided by 2 into c minus d. So your c is x plus del x minus d, d is your x. So this x and this x is cancelled. What is remaining? Del x. So del x comes top and c minus d by 2. So 2 comes in the denominator. So this x and this x will be added and becomes 2x. Okay. So this x del x will be written here and it is divided by 2. And this sine del x by 2 will be written as given above. Now we divide the numerator by 2 because 2 in the denominator. So 2x upon 2 will be x and del x upon 2 will be del x by 2, and minus 2 sine we write in the front side into sine del x by 2 we write here. So the formula of differentiation of any function by the use of first principle of differentiation is dy by dx is equal to limit del x tends to 0 fx plus del x minus fx divided by del x. So this numerator portion we have solved and the answer is this. So we write minus 2 sine x plus del x by 2 into del sine del x by 2 and divided by this del x. So similarly this 2 comes in the denominator and becomes del x by 2, and this minus sign we write here all the remaining things sine del x plus del x by 2 and sine del x by 2 is similar as shown in the numerator. So this is again sine theta upon theta as we have done in our previous question. So we write this minus sine x plus del x by 2 and this sine del x by 2 upon del x by 2, and we know that when the limit del x tends to 0 sine del x by 2 upon del x by 2 is 1. So when this becomes 1, so 1 is multiplied with sine, so there is no effect on that. So this becomes limit del x tends to 0 minus sine x plus del x by 2. So when limit del x tends to 0 means this del x is 0. So 0 upon 2 is 0. So what is remaining? Minus sine and this x only. So this becomes minus sine x. So your dy by dx will be minus sine x. So we know the differentiation of cos x will be minus sine x. So that formula comes from this first principle of the differentiation. So I think you are aware about the first principle of differentiation and finding the derivatives of sin x and cos x by the first principle of differentiation. So thank you so much. So we will meet with our new lecture with a new topic. Thank you so much.